Smart Minds tutorial.
So let us cover some important LAQs from continuity chapter. So we will cover all the questions based on continuous functions. So take the first question. Prove that a real valued function f is continuous at x naught belongs to domain of f if and only if for each epsilon greater than 0 there exists a number delta greater than 0 such that if x belongs to domain of f and mod x minus x naught is less than delta, then mod f of x minus f of x naught is less than epsilon. So let us say the sequence be xn. Then xn belongs to domain of f such that limit of xn is equal to x naught. Let epsilon greater than 0, then there exists delta greater than 0 such that x belongs to domain of f and mod x minus x naught is less than delta. What does that mean? That means mod f of x minus f of x naught is less than epsilon. Now since limit xn is equal to x naught, then there exists n greater than 0 such that if small n is greater than capital N, then mod xn minus x naught is less than delta. That implies mod f of xn minus f of x naught is less than epsilon. Therefore, limit f of xn is equal to f of x naught. Now, let f is continuous at x naught. Then there exists epsilon greater than 0 such that for any delta greater than 0, there exists x belongs to domain of f and mod x minus x naught less than delta, but mod f of x minus f of x naught is greater than or equal to epsilon. Let us say delta is equal to 1 by n. Then there exists xn belongs to domain of f, then mod x minus x naught is less than 1 by n, but mod f of xn minus f of x naught is greater than or equal to epsilon. Therefore, limit of xn is equal to x naught, but limit of f of xn is equal to f of x naught fails because mod f of xn minus f of x naught is greater than or equal to epsilon for all n. Therefore, f is not continuous at x naught. Hence, it is a contradiction. Contradiction means what we have assumed is wrong. So you can see here we have assumed let f is continuous at x naught. So this is not satisfying. The condition fails here. That means it is a contradiction, which means f is not continuous. Now let us take the next question. This is also very important. Prove that each of the following functions is continuous at x naught in verifying the epsilon delta property. So 4 functions are given to us. we need to show that each of the function is continuous at x naught. So let's start with the first one. Given f of x is equal to x square, x naught is equal to 2. That means f of x naught is equal to x naught is 2, right? So how will you get f of x naught? In the place of x, if you put x naught, but x naught is 2, so in the place of x, I am putting 2. So you will get 2 square. That is 4. So by the definition of continuity, what is the definition of continuity? Limit x tends to x naught, f of x is equal to f of x naught. Mathematically, we give continuity definition this way. So that means limit x tends to x naught, f of x is equal to, now in the place of x naught we put 2, x tends to 2, x square. So that is 2 square, which is equal to 4. But 4 is nothing but f of x naught. This is equal to f of 2. Therefore, f of x is equal to x square is continuous at x naught is equal to 2. Now how to verify this? We need to do the verification for each function. So now let us do the verification for the first bit. So for every epsilon greater than 0, there exists delta greater than 0 such that mod f of x minus f of x naught is less than epsilon. Whenever mod x minus x naught is less than delta. So here x naught is equal to 2. So let us consider mod f of x minus f of 2 is equal to mod x square minus 2 square. What is a square minus b square formula? A plus b into a minus b. So this is x minus 2 into mod x plus 2. This is less than or equal to mod x minus 2 into, now whenever we are separating the modulus, we need to put less than or equal to symbol. So mod x plus mod 2. So the bound for mod x plus 2 that does not depend on x and if mod x minus 2 is less than delta, then mod x minus mod 2 is less than or equal to mod x minus 2. So this is less than delta. That means mod x is less than, if I am taking minus mod 2 to the other side, we will get mod 2 plus delta. So mod x plus 2 is less than or equal to mod x plus mod 2. That is less than mod 2 plus delta plus mod 2. That is equal to mod 2 plus mod 2 is 4. 4 plus delta. Therefore, we can write mod f of x minus f of 2 is less than or equal to mod x minus 2 into 4 plus delta. Now let us choose delta is equal to 1. So mod f of x minus f of 2 is less than or equal to mod x minus 2 into 5. Thus, 5 into mod x minus 2 is less than epsilon, which implies mod x minus 2 is less than epsilon by 5. Now let us set delta is equal to minimum of 1 and epsilon by 5. That means it shows that mod x minus 2 is less than delta implies mod f of x minus f of 2 is less than epsilon. Therefore, f of x is equal to x square is continuous at x naught is equal to 2. So with this, the first bit is completed. Now we will do the next bit. What is given to us here? F of x is equal to root x naught is equal to 0. Then, how do I find f of x naught? In the place of x, we need to put x naught. But x naught is 0. So in the place of x, we need to put 0. That is root 0 is 0. So again, we use the definition of continuity here. By the definition of continuity, limit x tends to x naught, f of x is equal to f of x naught, which implies limit x tends to x naught, f of x is equal to limit x tends to x naught, or in the place of x naught we put 0. So limit x tends to 0 root x. That is root 0, that is 0, which is equal to f of x naught, which is equal to f of 0. So therefore we can conclude f of x is equal to root x is continuous at x naught is equal to 0. Now we will do the verification part. So let epsilon greater than 0, there exist delta greater than 0 such that mod f of x minus f of x naught is less than epsilon whenever mod x minus x naught is less than delta. Here x naught is equal to 0. So mod f of x minus f of 0 is equal to root x minus root 0. That is mod of root x, which is less than or equal to delta. So mod root x minus 0 is less than epsilon whenever mod x minus 0 is less than delta. Now you choose delta is equal to epsilon square. Then mod f of x minus f of 0 is less than epsilon, which implies root x is continuous at x naught. Therefore, f of x is equal to root x is continuous at x naught is equal to 0. Next, let us take the third bit. So what is given over here? Given f of x is equal to x sine 1 by x. So it is x sine 1 by x when x is not equal to 0, and it is 0 when x is equal to 0. So by the definition of continuity, limit x tends to x naught, f of x is equal to f of x naught. So limit x tends to x naught, f of x is equal to limit x tends to 0, 0, that is equal to f of x naught, which is equal to f of 0. Therefore, f of x is continuous at x naught is equal to 0. Now let us do the verification part. Let epsilon is positive. There exist delta greater than 0 such that mod f of x minus f of x naught is less than epsilon. whenever mod x minus x naught is less than delta. Now consider mod f of x minus f of 0 is equal to mod sine x sine 1 by x minus 0. That is mod x sine 1 by x. That is mod x, if we take out, we will get sine 1 by x minus 0. That is less than or equal to mod x into 1. Why? Since mod sine 1 by x is less than 1 for all 1 belongs to x of minus infinity comma plus infinity. So this is less than delta. Understood? Now let us choose delta is equal to epsilon. Then mod f of x minus f of 0 less than epsilon, or mod x sine 1 by x minus 0 is less than epsilon whenever mod x less than delta or mod x minus 0 less than delta, which implies x sine 1 by x is continuous at x is equal to 0. Therefore, f of x is continuous at x is equal to 0. Now take the last bit, that is d bit. What is given to us? Given g of x is equal to x cube, where x naught is arbitrary. So by the definition of continuity, limit x tends to x naught, g of x is equal to g of x naught. So limit x tends to x naught, g of x is equal to limit x tends to 0 x cube. So that is 0 cube, which is equal to 0. That is g of x naught. Therefore, g of x is continuous at x naught. Now let us do the verification. Let epsilon greater than 0. There exists delta greater than 0 such that mod g of x minus g of x naught is less than epsilon whenever mod x minus x naught is less than delta. Here x naught is arbitrary. Consider mod g of x minus g of x naught is equal to mod x cube minus x naught cube. That is mod, what is a cube minus b cube formula? A cube minus b cube is a minus b into a square plus ab plus b square. This formula I am applying here now. X minus x naught into x square plus x naught x plus x naught square. This is less than or equal to, if you separate it, we need to put less than or equal to symbol. X naught x plus x naught square. Okay. Now you choose delta less than or equal to 1. Then mod x minus mod x naught less than or equal to mod x minus x naught, which is less than delta. So mod x, if I take this to the right hand side, we will get less than or equal to mod x naught plus delta. So mod x is less than or equal to mod x naught plus 1. Why? Since delta is less than or equal to 1. So mod g of x minus g of x naught is less than or equal to mod x minus x naught into mod x square plus x naught x plus x naught square. I again use the same formula. Now here we are separating it again. Mod x minus x naught into mod x naught plus 1 whole square plus mod x naught plus 1 into mod x naught plus mod x naught square. So what did I do here? In the place of x, I used mod x naught plus 1. So this is less than or equal to mod x minus x naught into 3 mod x naught square. If I open the brackets, we will get this mod 3 mod x naught plus 1. Now, let's say n is equal to 3 mod x naught square plus 3 mod x naught plus 1. Then mod g of x minus g of x naught is less than or equal to n mod x minus x naught. So choose delta is equal to minimum of 1 comma epsilon by n. So for any epsilon positive, there exists delta is equal to minimum of 1 comma epsilon by n such that mod g of x minus g of x naught less than epsilon whenever mod x minus x naught is less than or equal to delta. Therefore, g of x is equal to x cube is continuous at x naught.